Great. Hello, everybody, and welcome to today's lunchtime webinar on image quality-driven exposure control in fluoroscopy. Today, we're going to hear experiences from Charlotte Porter and Greg Stevens following the installation of their image quality-driven fluoroscopy units. We're then going to open the floor up to yourselves for questions, experiences. Please tell us the highs and the lows. And we hope that this will spark the conversation within the community so we can share our knowledge and highlight some common questions that we've all got. So just before we start, there's a few housekeeping points. So this webinar is being recorded and will be uploaded to the IPEM conference's YouTube channel after the session, so you can rewatch it there. We're also using Slido for our Q&A session. So you should have either received a pop-up in the top corner to open the Slido bar, or there's a link in the chat to open the web browser version. So if you pop your questions in there throughout the talks, then we will bring them up at the end there. So to get us started, just to kind of get a feel for who we've got on the call today. We've got 3 quick questions just to get a feel for his audience today. So if you could pop in your answers to that one. So we're just wanting to get to know what your involvement is with fixed fluoroscopy equipment in general. And then if you've got anything that doesn't fit those topics, as I'm sure we do a whole range of things, then there's a free text box coming up in the next one just to detail the other section. So it seems most of us are involved in routine testing and commissioning, but a good proportion of us have got that more detailed involvement in procurement and specification. Cool. Okay. So just if there are any other big sections that people are involved in that weren't covered, don't know if we've got any radiographers or application specialists or anything else. Cool. So I should have done optimization. Yeah. That's the topic. Cool. Okay, so our next quick question is then whether you've got one of these image quality driven fluoroscopy units in your remit. Okay, so half the call maybe has got one of these. That's good to know. We'll be picking your brains perhaps in the question section, but looks like lots of people are here to get an insight into this type of equipment. And then finally, if you have got one of these image quality driven fluoroscopy units, what kind of work is this unit supporting? So it's covering a good range of the different types of fluoroscopy work then, perhaps most notably cardiac and neuro then. Amazing. Right, well, without further ado then, I'll now hand you over to Charlotte Porter, who's going to talk about her experiences and the journey of the equipment that's based in Leeds, including some already achieving some optimization.
Thank you very much, Hannah. I'm just going to share my screen so I can control that. Can somebody give me a heads up if you can see it?
Yeah, we can see your slides
Okay,
now.
lovely, thank you. Okay, so my name's Charlotte. I'm one of the medical physics experts at Leeds Teaching Hospitals. I was asked today to kind of speak to our experiences locally. I cannot profess to have all the answers to all the questions, so I'm sure there'll be other people in this call who might be able to chip in as well. But I'm just going to give you a bit of an outline of our experiences, what I've been able to establish about the CNR regulation the system does. A couple of issues we had at acceptance that people who've got these coming soon might want to think about. We did have a few incidents shortly after it was installed, and we've learned from those incidents. So I thought it's worth sharing a bit of that with the call today. We've done a bit of optimization work, and I've also got a bit of dose information at the end, in case that's helpful for anybody who's got one of these systems or is maybe doing some procurement exercises at the moment. So our Icono was installed in June 2023. It was exclusively for the neuroradiology service, and it replaced a very old biplanar room, which was a Philips Aurora installed in 2009. To give a bit of an outline of the work that we do, the LGI is a major trauma and specialist stroke centre. We had 525 patients go through on the old Philips system in 2022, and we do quite a wide range of work, including some quite complex work. And to date, or to the 31st of May, we've done 435 cases on our new system. So obviously we know, that's why we're here, that this system does not work in the way that we are used to historically with our fluoroscopy systems. So it aims to achieve a specified contrast to noise ratio in the image. I'd highly recommend this white paper that Siemens have published if you're getting an Icono, because it does go through a bit of the detail on what they do. So essentially is the system is trying to select exposure factors that will give that specified contrast to noise ratio at the lowest possible patient entrance surface dose rate. Siemens, they described it multiple times as a jungle of exposures to me. Apparently there are about 300 million different possible combinations. So obviously this is quite a complex piece of kit, and sometimes it can pick maybe quite different exposure factors to achieve that specified CNR. So quickly, a few issues that we noted that I thought it was worth mentioning. When it was installed, we found that the red part of the illuminated warning light pulsed with the frequency of the radiation. They did have a fix for this, so we asked them to instigate that, but it did give us a permanent error message. Siemens said that there's a fix in upcoming software upgrades. To be quite honest, I've not been down to our system to check whether that's been implemented yet or not, so it's worth checking, I guess, to see whether that pulsing still happens and if that error message is still present. Then obviously it goes without saying, we're not necessarily in a dose-regulated world anymore. We found very quickly that all of our detector input dose rate testing with copper did not work. I'm not going to dwell on this because I know that Greg's going to speak about the QA side of things a lot more in a few minutes. But the system is aiming to achieve a given CNR, as I've said, so it's expecting contrast in the image. So if you give it a flat field, then it's going to struggle. And it is also expecting a certain beam quality, which is certainly not the hard beam that you get when we put a lot of copper into it. So locally, we chose, though I'm sure other people might choose to do things differently, we chose specifically for the detector input dose rate testing to do some of our testing on the service in regulation program, because that isn't contrast noise regulated. That is the standard dose regulation that we're used to seeing on older Siemens systems. We've also currently instructed our radiographers to carry out their QA on that service and reg program, because the results were just not repeatable with the equipment that they had, which was copper. So for now, that's the route we've decided to go down. I'm sure we'll discuss alternatives in the rest of the webinar. So when we were testing it, we found the protocol editor, which may look fairly familiar, but there's some key differences. So this is my disclaimer. This is how I think the system works based on conversations I've had with app specialists. I highly recommend you speak to your own to make sure that that I'm right, I guess, and to make sure that you know what's going on locally. If you are getting one of these installed shortly, I highly recommend that you insist that Siemens give you an app specialist for at least your first day of testing. We had an app specialist with us the whole time we were there, and their input was invaluable. And I peppered them with questions constantly. So I'm sure he was exhausted by the end of it, but I found his presence very helpful. So I'd recommend that you do the same. So One of the first things on here is this CNR box. It's a yes or a no. If it's yes, then it's going to be a protocol that uses contrast and noise regulation. There are these two elements here. So the objective interest, so you have to specify for a particular protocol what the objective interest is. So it could be iron, tantalum, iodine, CO2. It will depend on what the clinical task is that's being kind of achieved with that protocol. And then the image quality level is set. So that is essentially the CNR level that the protocol is requesting that the system aims to achieve. This reference water value down here is the system is aiming to give that CNR for a patient of that water equivalent thickness. So you may ask, how does it deal with thinner or thicker patients? And this value here is how it does that. So it kind of tells the system how to modulate to account for patients that are either thinner or thicker than that specific reference water value. Now, I don't know about you, but I thought that sounds quite a lot like CT tube current modulation. So this is a graph from Siemens of how their CT scanners adjust the MAS for their tube current modulation in CareDose 4D. So we're similarly specifying a particular image quality level or effective MAS for a patient of a certain size, and then telling the system how we want it to respond, whether very strongly or weakly, to patients who deviate from that particular thickness. So the other couple of things I wanted to pull out, the system for each protocol will set a legal maximum air camera rate. I'm fairly sure this is low, medium, or high, and I think it corresponds to the different IEC dose limitation standards. This value of actual maximum air camera rate, if I'm honest, I can't remember when I was putting this together this week, whether that is specified at the interventional reference point or whether that's at the FDA reference point. That would be something that's worth checking if you're wanting to actually test the dose rate limitation on the system. But essentially, the system will modulate up to that maximum air camera rate, and at which point it shouldn't go any higher. I think anecdotally, I've heard that for thinner patients, the system's quite good and the doses can be quite low, but I think the system has the ability to give quite high doses for larger patients. So that might be something to be aware of. Obviously, we're using the system in neuro, so there's only so much variation you get with heads. But for those of you who are going to be using it in more general purposes or in cardiac, it might be something to be aware of. So the final note that this is all normalized to a given field size or zoom factor. So it's normalized to a 22 centimeter field size, which interestingly isn't a field size that exists on the system. So that's just something to bear in mind if you're wanting to do a bit of maths to figure out what kind of dose rates you should be expecting at different field sizes. So I wanted to talk a bit about the peak skin dose indication as well. So if you enter the height and the weight of the patient when you're registering them, then the Icono will give you a peak skin dose indication. So this happens both during the procedure and also at the end of the procedure. So there's a color scale on the screen, and it gives us quick indication for the operators. I think this can be set at any value you want. So that's quite a useful quick check for the radiologists or cardiologists who are using the system. We had some concerns initially because spoke to the app specialist. When we started getting some of these peak skin doses through, we weren't really sure exactly what was going on. The specification wasn't really clear enough to establish whether that peak skin dose was looking at tube A, looking at tube B, and giving you the highest of the two values, or whether it accounts for the overlap. So our app specialist didn't know, so they fed that to Germany, and the guy who got back to me said he didn't know either. So he went off and did some testing and said that thankfully that it does account for the overlap, so that's good news. But we still have some queries about how accurate that peak skin dose indication is, as I will show you now. So after we had the kit installed, we did have a couple of cases of radiation-induced hair loss, which were reported. So these were complex cases, so they weren't straightforward. The screening times were really large. So obviously we would expect there to be a reasonable peak skin dose for these patients. But this isn't something that we'd seen for years and years and years. So it was obviously something that was of concern with our new equipment. So we did quite a lot of work to look into it. First thing to say, unfortunately, because the patient height and weight wasn't entered, we weren't able to get the peak skin dose off the Icono system at the time of the incident. So what these two columns here are showing you are the peak skin dose that was indicated by the Icono and the one that was indicated by our dose management system, which is CALM. Of note is this value here. Now, obviously, 1.7 Gray is below the threshold at which we would expect to see hair loss. So this is the point at which we were really thinking, okay, we need to do some work here to look at how accurate these values are and which is the one that we should be using. So for the time being, we've implemented for our high skin dose protocol that we're basing this on cumulative air coma instead of peak skin dose until we can establish a bit more about the accuracy. We've also got different levels in place for neuro compared to all of the other IR and cath lab procedures. So, for example, when a patient receives a cumulative air coma of more than 3 Gray, and that's taking into account other examinations they might have had in a short period of time, then we'll put them into an active follow-up procedure. I'm very happy to share the details of that with anybody if they do want to know what we're doing locally. So optimization, obviously, we realized after these incidents we needed to do a bit of work. The first thing to say is one of the radiographers noted quite early on that the pulse rates for the roadmap were at 10 pulse per second and the old system had been 7.5. So it goes without saying, it should be obvious, obviously, that you need to make sure that any of the default settings that come with the new kit are sensible and are in line with your expected examination protocols. So the first change we made was obviously to get the app specialist to drop the pulse rates on the road mapping. We also got them to drop that image quality level for some of the fluoro triplets, so the FL minus, FL and FL plus, and we got them to drop the image quality level for the DSA program. So these are the 3 programs that were altered. So these were the values before and after. So the numbers in red are the ones that have changed. And so obviously you can see we've lowered some of those values. It's much more difficult with a system like this to establish actually what effect that is going to have on the dose the patient gets. So obviously ordinarily with another system, you might say, oh, I'm going to drop the pulse rate, the dose per pulse, sorry, by a given amount, and you'd have a reasonable idea of what effect that would have. But it's much harder to translate any changes you're making into the effect it will have on the patient. Following this, we had some more work done. So with the DSA care program, very soon after that change was implemented. So we did it in line with the radiologists, and they did some cases with the app specialist present, and they were happy the image quality was good enough. Then another radiologist came and used the system and decided he wasn't happy. So that value got increased a bit. And then some other values have subsequently been changed as well. So we're still bedding in with this, and there are still some changes that are being made. One thing I wanted to say was the app support we've had throughout, actually, so from the installation and with the incidents as well, has been fantastic. The 2 application specialists I've had interaction with have been really knowledgeable, really helpful and very patient with all my questions. And they've also been very happy to forward any queries onto Germany when necessary, and they've got back very quickly as well. So that has been a very positive aspect of our experience. So I'm just going to finish off with about dose. So the system has many field sizes, as I'm sure everybody will be delighted to hear if you have any involvement testing it. The dose rates for the 13 and 10 centimeter fields are very high. So high, in fact, that Siemens applications make it very clear that you shouldn't be using these field sizes at all. I think you could probably imagine my response to being told that. So this is something they really drill into the radiographers at when they're training them. So now when our radiologists request maximum mag or the smallest field size, the radiographers go to 16 and they tell them that there's nothing more, that's it then. So yeah, the messages don't use 13 and 10 centimeter fields. When we were testing the system initially, we did the IPEM 91 maximum patient intrasurface dose rate on the largest field size test. These are the details of the program we did that on with 18 centimeters of perspex. It was over the remedial limit of 50 milligrays per minute. We then did the testing to assess whether the system was compliant with the IEC standard with respect to the maximum air coma rates, and it did pass those tests. I've not repeated this test. We've not quite got around to the annual QA for it yet. I would anticipate that since we've dropped that IQ level, we may find that that is no longer exceeding the remedial limit. But essentially, the system is capable of delivering some pretty high dose rates, so it's worth optimizing and worth keeping an eye on it. But to finally give you a bit of DRL data, so these are the 3 procedures for which we have local DRLs, and you can see that we have had a between 25 and 30% reduction in our local DRLs following the Icono being installed. So that's obviously really, really positive. Little note on the data, the Allura was too old to connect to our dose management system. So it was, may have had a bit of human error thrown in there, as we were all aware of, but in general, I think the data is pretty reliable and does show a reduction. The data for the Icono was correct as of April, after we'd done the optimization following the incident. However, the apps came back in May, and they've done those tweaks so that kind of final column I showed you earlier, and increase the image quality level again for some of the programs. So I've not had chance, obviously, to see what effect that has had. I'm assuming it's still going to be far below the old system in terms of the doses, but the radiologists were still a bit unhappy about image quality. I think they were unhappy with the spatial resolution, but it can be quite tricky to ascertain exactly what it is they're wanting sometimes. So I can't speak yet to the impact of the changes that have been made. But as I said, I'm anticipating that the doses are still going to be significantly lower than we had on the previous system. So to summarise, the equipment operates in a very different way to what we're used to. So it was very challenging to test, and I will leave that to Greg to discuss. There is the potential for some high dose rates, and we've seen some tissue effects. So optimization is important. And as we found out, as is having an SOP for identifying and managing any high skin doses. Engagement with the app specialist is really, really key. And on average, our doses appear to be lower than the previous equipment. So that's me done. I hope that was of use to everybody. Thank you very much for listening.
Thanks, Charlotte. That was really insightful account of all the different stages you've been through there, from installation of your equipment. It's great to see that there's lots of optimization possibilities, and the doses are better than your old equipment. That's always great to see. So I'll now welcome Greg to talk about his experiences with his system, with a focus on undertaking routine QC testing.
Right, it does help to unmute, doesn't it? So we got 2 biplanes. One was installed in August last year. The other one was installed earlier this year. I should add that we've just had that software update and the pulsing's been fixed. So also Siemens run on the IEC standard, so that also helps. And finally, I believe Andy Rogers is organizing a user group. Now, I know he did that for Philips, which is our previous iteration, and that was extremely useful. That cut our doses down by at least half. So I would encourage everybody to get involved with that. The other thing is that our second patient we had was a TIPS patient. Our median dose for TIPS is about a gray, and this was significantly higher than that. And again, that was simply down to the field size. If you do use the 10 or the 13 field size, it really does. It takes you about 3 minutes to actually hit that 2 gray limit. So it's really quite scary doses. But I've also got to reiterate actually that in terms of how the system the system was actually operating exactly as Siemens designed it. So whether Siemens didn't realize this would be a problem during the development phase, really do not use those two field sizes because they're eye-wateringly high doses. The other thing that has hit me more is that this is a collaboration between the manufacturer and the trust, and you really do need a real collaboration between your radiologists, even if they're not interested in partaking, your app specialists and physics. So I really can't emphasize enough how much more you've got to get involved, and do not take anything as assumption. I've had over 10 years fluoroscopy experience, and this is really by far a completely different system. And while I might sound like I'm whinging a lot, I've got to say actually that certainly for thinner patients, our doses are considerably lower. For fatter patients, or bariatric patients, sorry, they tend to be higher. But on average, the cumulative doses are lower. So stuff that I do definitely know about, the recursive filter is on all the time. So a recursive filter is something that just takes a proportion of the previous image and adds it to the new image. So your signal goes up, your noise goes down. This is absolutely fantastic if you've got stationary objects, because effectively what you've got there is a lot of averaging. Which is great, but it gives you a false result for your image quality. So just bear that in mind. The CNR feedback mechanism is really quite high sensitive, as Charlotte mentioned, to high attenuating materials. And I think actually I suspect that the system is actually inherently unstable. So it just moves around the equilibrium level. And when you put in something like a high attenuating material, then that movement becomes quite chaotic. I'd recommend you getting Siemens to put a physics mode in, a sort of physics testing mode. We've got a physics testing mode which just stops the removal of copper. It just makes life a little easier because then you've got one less parameter to deal with. The other thing is that the system does not change filtration on the fly. So if you put your foot on the pedal and the system wants to change the amount of copper in the beam, it will only do so on the next exposure. So just bear that in mind, because we ended up getting all sorts of weird numbers, and nothing was consistent, and that was one of the main reasons for that. I really highly recommend getting the DICOM files off, so you can get those off straight. You can just put a safe stick into, well, as shown there, you put a safe stick into the sort of on button module, and you can pull the images off directly. That's really quite useful. And the DOI link there is actually from a guy by Wernick, who works for Siemens and explains CNR based system. So I highly recommend you get that paper as well, because it seems to it gives you an awful lot more information than I'll be doing here. So if you put copper in the beam, these are the kind of traces you get, and what you might notice is this kind of slightly wavy pattern. That's not the only one you get. The one down below is just at a different field size, and it goes from being a nice stable trace to a slightly chaotic trace, back to a stable trace, back to a chaotic trace. It's just not enough room to actually show that on here. And then with PMMA, you can see that trace settles down very nicely. So hence, probably time for us to stop using copper. The other thing that's quite interesting is just how fast the system reacts. So I did a lot of messing around with taking everything out the beam and then putting a whole 20 or 30 centimeters of PMMA in the beam, and it reacts within a pulse. So our pulses are 7.5 frames a second. Within a pulse is pretty quick for most electronics. The other thing is that our PMMA, I don't know about everybody else, but certainly ours is a bit battered. Got lots of bits of micropore and stuff like that glued to it. And the problem there is that the system seems to lock onto the PMMA, lock onto the micropore, and you start getting all sorts of weird numbers again. So make sure your PMMA is fairly clean. The only reason I realized that is because I started using our mammography PMMA, which is 1 centimeter thick instead of the 2.5 centimeter thick PMMA we use for diagnostic. And the 1 centimeter thick PMMA gave me much better results. However, consistency is a bit of an issue with the system. That image just shows you how we mentioned the dose rates at the interventional reference point. So this just allows you to check the what the displayed dose rate is compared to what we're measuring. So it's just a single piece of PMMA there with a dose meter attached to it. What I will, and we're getting about between a 20 and a 30% difference between the two planes. We've only got biplanes, so those are the only things I have any experience of. For acquisition, you might notice that the initial run runs at a faster rate than the actual reported run, and you will need to increase the scene length, which I've circled down at the bottom. Otherwise, you're just not going to get the correct bits of dose, and obviously you've got to stop. You've got to stop measuring that fast pulse rate. So for here, it's about 2 seconds. This is for our neuro protocol. The other thing is that if you're measuring things like patient dose and stuff like that, we like to do it in as close to a clinical way as possible. Your detector, whatever that happens to be, has to be outside the active area, and you can see there's a whole load of active areas that you can choose from. Just make sure that your detector isn't inside that area, because if it is, your detector will have a much bigger impact on the values that you get out. The downside with that is that because magnification, your detector, you've got to have quite a small detector, smaller than the UM4's ZX size. If you're actually going to be within that, outside that active area, it becomes quite difficult to actually measure. The other thing that's quite handy about this is actually you can get the sort of the patient doses and compare them to the derived doses at the same time. This is just an example of some of the data that we've got. You can see that we've got a fairly good distribution, but a fairly tight distribution between the A plane and the B plane. And so far, actually, the most useful thing we've done is to measure the kPMA curves. And what I'd like to draw your attention to is actually the main parameter to cope with different thicknesses. That's actually the pulse width. So you can see the pulse width, which is the bottom right-hand side curve, is wiggling all over the place, whereas the rest of them don't really move that much. So that's very different to the old systems. The other thing, of course, is that under the old systems, your copper filtration would be a function of the fluoroflavor if it was Philips, but essentially your low, medium, and high dose buttons, that's no longer true. So copper filtration happens about halfway through the medium, the normal range, and then drops quite rapidly after that. Now, when I complained about the fact you got a recursive filter in there, you can still measure image qualities in sort of, but this is kind of the maximum image quality possible on the system. And what I've actually done there is I've just set the the system up so that I've got 15 centimeters of perspex on the couch at the interventional reference point, which means that the test object's at the ISO center, and that makes it much easier just to rotate the A and B plane simultaneously and then do the measurement for the other plane. It just makes your life a little easier. And that gives you a kind of a maximum image quality, but beware that that is not the clinical image quality that your clinicians will be seeing. Because of the recursive filter, we started playing around with some kind of dynamic image quality. We've got a Motus Phantom. We've also got a DSA test object. The DSA test object works very well. The one we've got is a Leeds one, I believe. The Motus, however, is quite interesting. So this is that image is a TO10 with the actual movement on at the time, and you can see that there is an awful lot of ghosting. This is down to, I'm assuming this is down to the recursive filter, because it wasn't going so fast that that shouldn't have been an issue. So we will need a new test object, effectively, a new image quality test object that is far more closer to what the clinicians are seeing, or what the material that the material that the clinicians use. So obviously some sort of PMMA, but the idea of using these hard metal objects is really a no-no, and you can't have a lot of them in the system. I've also put in little plastic pipes and squirted well, some contrast through there, and I don't get the same ghosting effect. So I'm not entirely sure. There's obviously some active image processing going on. So there are obviously ways of tricking the system, and that's actually part of my HSST project. So I'm going to try and do some kind of image quality phantom for QA, for interventional. Finally, all our thrombectomies now have at least one cone beam CT. So I kind of feel that it's at least important to do that. Stick a CAT fan on there. You won't be able to get any of the pixel values out, so you're not going to get any quantitative data out of there, but you can at least look at the numbers and the various sort of Hounsfield areas and stuff like that, and make sure that doesn't change. And again, if you save those DICOM files, then you've got them as a consistency measure. And that's me done.
Thank you, Greg. I think you've done a lot of work there that we'll all be benefiting from as we continue to test these year after year and increase our understanding there. So I hope you've all now got your questions at the ready. I can see a couple have started to come in the Slido section. So I think I'll get straight in there with some of the first questions. So Charlotte, I think this one's kind of towards you. How did you decide initially on how far to drop your image quality level as part of your optimization?
That was entirely based on the advice from the application specialists, because yeah, like I said, it's hard for us to know with only one system and not really being able to directly relate that to an impact on dose, what to drop it to. So yeah, we were going by the advice from the application specialist.
Perhaps this is something when we are all optimizing various systems, we can go, oh, we use this image quality level, perhaps share that information about.
Yeah, I think that would be really handy.
Cool. Then the next question, were measured receptor dose rates tested with any attenuation materials other than copper, for example, water or perspex, with the CNR mode on, and found to be any more sensible or repeatable?
Only so far. So we tried a whole load of different things, including iron. So we've got a workshop downstairs, and I grabbed a load of bits of things like some very thin copper, That caused a problem. Aluminium caused a problem. Essentially, I think the way the system works is, like I said, it is inherently unstable. So what it physically does is it just varies between too much and too little. And if you haven't got a huge amount of attenuation in the beam, or at least the attenuation that it thinks you should have, then it's almost unnoticeable. But as soon as you put something thicker in there, that becomes very chaotic. So I think actually the actual system is inherently unstable.
That'll be something we're all testing out various options for, I'm sure. So there's Debbie's asking for ideas. So they have a icon for basic cardiac work, and got some problems with the sternal wires and implants causing higher doses. If anybody has any ideas for alternative protocols with different optimization materials, or moving to turn off the CNR.
It's a very good question. I kind of wonder what's going to happen when we have somebody with a large implant. Is the system going to be stable at that point? But so far, and I'm talking from 6 months experience so far, the system has been really quite stable and really good image quality. So I can't fault that. I think the problem comes when you go away from what the clinicians are seeing. That's when we start to have issues, because that's when the system becomes chaotic. As far as cardiac work is concerned, I can't really talk because I don't have any of that. And obviously you haven't got the recursive filtering for a cardiac system, because otherwise the heart beating would cause too many problems. So I'm not entirely sure what they would do.
Yeah. Okay. So maybe it's our testing needs to really replicate the clinical situation. Perhaps that's what we need to investigate. Right. Next question. Well, we're going with one of the newly posted ones from Timothy Lloyd. So for level A QA tests that have been undertaken by radiographers, are you still using copper for both dose and image quality, given the issues you highlighted? No,
definitely not. We got them some perspex, and that's been nice and stable, and they've got really good reproducibility. So that's what we're sticking with. The problem is, of course. Oh, sorry.
Sorry, I was just going to say, in Leeds, we're unable to source some additional perspex at the moment. So what we've done with the existing equipment that they've got is to tell them to use that service and regulation program that doesn't use contrast noise ratio regulation. Now, obviously, that's not necessarily representative of what the system's doing clinically, but it at least gives us an idea of whether there have been any large scale changes in the performance of the detector and the system. So yeah, that's what we've been doing for the time being, but we would like to work towards being able to test the actual clinical programs, obviously.
How much perspex have you implemented to swap the copper with, Greg? Just out of, do you know?
Yeah, I'm trying to remember now. I think it was about 10 centimeters. Okay. Just because that's the stuff we had available at the time.
Okay. There's a question here. Have Siemens provided a QA test object for the system?
No.
We've not got one. I think Siemens do actually have a way that they recommend their system is tested, but that document was not, they weren't able to share that with me openly. But I think you may find that off the record that if you have a friendly app specialist, they might be able to give you a bit of information on what it says. That's my understanding, having kind of had off the record conversations with people.
Yeah, I think once you start procuring one of these systems, you can start asking the questions of, I need to know how I can reproduce your tests to show that it is against your specification. Right. Through. Either of you doing SNR measurements for image quality? Or are we still doing the?
You can't. You'd need to get linear data. So we did ask Siemens for the NEMA standard, XR27, I think it is, which allows you to collect linear data, which would allow us to do SNR or CNR measurements. That's not been forthcoming, unfortunately. It's only NEMA is an American standard, obviously, and like Siemens said, it's not required in Europe. So that's kind of where we sit at the moment. I personally think that something along those lines is going to have to happen, because the reason we test fluoroscopy machines in the way that we do, measuring patient dose in the way we do, and eye face dose in the way that we do, is simply because the thing that's constant is the dose rate, or the acoma rate, whatever you want to call it. Now we've got a CNR rate. We've got to either be able to measure CNR, or at least be able to infer it from somewhere.
Yeah, it's fundamentally changing our thinking of what we're measuring, isn't it? So have you either of you tried measuring the CNR with the different types of materials in the beam from what it selects? Does it actually make a difference if you pick between iron and tantalanium?
So we got a number of different bits and pieces, including glass. I'm trying to think of all the various materials I grabbed hold of. Essentially anything above, anything above aluminium actually starts to show instabilities. And the further up the periodic table you go, the worse it gets. I mean, clearly these systems are made for tissue and a small amount of tantalum or whatever forms the stent, and the image quality is geared around really picking out that foreign body. I think when the foreign body happens to be a large proportion of the image, that's where we have a problem.
Yeah, we almost need a whole new set of phantoms to test this kit with. There's a question here on recursive filtering. So given the recursive filters, CNR-based exposures and stent enhancement software, is it time to start trying to assess clinical image quality on clinical images instead of physics phantoms?
You're going to have a hard time getting any consistency then. I think QA does have I think QA is necessary, because otherwise how do you say that the system is ready for clinical use without sticking your patient in? But once we start sticking patients in first, then aren't you using your patients as guinea pigs?
Yes, there's a whole unknown section there, really, doing QA on clinical images. Be interesting if anybody has even tried that. I don't know if anyone wants to jump in from the audience. No, maybe no one's doing it yet. Okay, this is an interesting question. How do clinical images compare with the older traditional systems? Do radiologists like the images? Have you had any feedback?
So we had an old Philips Allura, and it really was quite old. So it didn't have clarity. And the current image quality is vastly superior. So they are able, well, the image quality is vastly superior when they stop moving things in the beam. One of the initial problems we had was that most radiologists are used to wiggling catheters to improve visual acuity, which works really well on the old systems and also works very well with things like ultrasound and so on and so forth. So it's born in their experience. The problem here is as soon as you do that, the averaging or the recursive filter stops because you're moving something in the beam. And so consequently, your image quality drops. So one of our biggest problems, well, one of our initial problems was that the radiologists claimed they couldn't see anything because, of course, they were moving everything all the time rather than just settling it down for a second or two.
So perhaps some training required to kind of adapt how they perform these procedures and techniques they've developed for the older, different
that's why I said
system.
That's why I said there is a real. This has to be a real collaboration. The days of the radiologist not caring and going off to their office while apps training happens, and physics not attending apps training, is something of the past. I don't know if this type of system is going to be the next thing. It may well be. I don't know. But certainly the image quality is really good, and we're seeing lower doses on average. So it's likely to.
Yeah, just to add to that, in Leeds, I think we've had a similar experience in that the Allura system was very old and didn't have clarity, so the image quality is vastly superior to what they were used to. I think they are not quite happy with it yet. It would be interesting to have a conversation with them and observe them to see if what Greg is talking about is maybe part of that issue. But I think part of the problem as well is that they went and saw the system being demoed, I think, somewhere on the continent. It may well be, obviously, that the image quality they had over there is much higher and the doses are much higher as well. So I think it's about balancing expectations as well. But I imagine as more of these systems go in the UK, in the procurement process, they might go on UK site visits rather than abroad, and they may get a more clinically realistic idea of what's going on based on other UK centres.
Yeah, so I think that's definitely a takeaway point, isn't it? To get the full multidisciplinary team involved from the start, in order to do so. Here's another question on the processing. Do you know if the processing includes an image stacking parameter? Siemens have this on their CIOS mobiles, and we've had issues with stepping and ghosting. It's been solved by reducing the image stacking. Is that going to be a recurring problem?
So I suggest yes. I don't know whether they call it that, but there's definitely a recursive filter which is effectively doing that. You're averaging over. Well, if you have a look at that, the slide where I had the Motus Phantom with TO10, you can count 5 separate bits of ghosted image. So clearly they are doing that, and that was at a 7.5 frames a second image. So yeah, there is the equivalent of that. Whether that's what they call it in the protocol, I don't know. In the database, I don't know.
Okay. So another question here on actually is performing the QC. So how are you measuring patient entrance dose rates for the smaller field sizes without having your dose meter affecting the dose rate? A continual challenge, maybe.
So the major issue is that at the moment we're using a needle. What do they call them? The transparent from the Unfor's XI. This little transparent detector, which is perfect because it's about it's about 0.5 centimeter by about 4 or 5 millimeters. So even with the magnification, you're still within that parameter, and you can keep out the active area. I tried to use a 60cc chamber, a 6cc chamber. Just the fact that they changed the contrast, and there is a difference in contrast of those objects in the beam in the active area affects the dose. So you really need everything out of that active area, and that's really tough to do. They do have one mode that has 2 active areas essentially as a couple of rectangles, and you can get an unfors in there, but you've got to be so careful because it's so easy just to have it drop into one of those active areas. You don't have a lot of room to play with.
We use an ionization chamber, so obviously we don't have a solid state chamber in the beam, but like Greg says, it does still impact it. So I guess you might want to just add an extra column to your QA spreadsheet to say specifically which sensing area you're using, maybe, and yeah, think about just ways of adjusting your work instructions to make it as repeatable as possible. But yeah, it's hard.
I just noticed what Debbie said about RaySafe not interested in making a transparent detector for X2. That's absolutely true. It's not made anymore. We're just lucky to have one.
Yeah, so perhaps, as you suggest, recording the exposure factors for the small field is a step, so that you can at least know it's whether it was in that much or not, I guess. Cool. Right. I think we had a bit of an answer for the previous question about the filtering, that they use the same K factor as on the mobiles, for Fiona's question there. So there's a question here about, for people who have experience with this kit, how many issues are people having with downtime of the kit?
To the best of my knowledge, we've not had any, but nothing that has necessitated them contacting physics to say that we need to go and do any testing, at least. So
we had major issues with it, mainly because our air handling units weren't running properly, and the detectors especially are really sensitive to changes in temperature, which caused all sorts of issues. All sorts of problems. Ended up with almost having to recommission one of the units. So I can see problems later on as the system gets, as the system ages, and your air handling units become slightly less efficient. It really does belt out an awful lot of heat. So that's one problem. The other issue is we've had a lot of, I think to be fair, we did a lot of whinging when the systems first went in, and we had apps in maybe 7 or 8 times, and got told that it's all our problem. We're the only ones that are having problems like this in the whole of the world. I kind of think that I think Siemens are realizing that they need to step up and be a little bit more proactive here. And that's not me saying that was exactly the same with Philips previously. When we first put the Allura in, the dose rates were eye-watering, and it took quite some time to actually lower those to something that was reasonable. I think the same iteration is going to happen here with Siemens, and I think that's just because of the commercial world that companies exist in. I don't think that's a reflection specifically on Siemens itself, or on Philips for that matter. They're both pretty good companies.
Just to quickly add in as well, with regards to the air handling unit, we've not had issues with the system since it went in, but the whole project was significantly delayed by having to resort out the air handling units before it went live. So yeah, that is definitely something to make sure that your estates and facilities teams are fully up to date on and can sort out, I guess.
Yeah, okay. Well, I think we're about to run out of time, but Andy Rogers, did you want to unmute and say something about the Siemens?
Yeah, can you hear me all?
Yes.
Okay, great. But firstly, thanks, Greg and Charlotte, for your experiences. I think we're all experiencing this. So the idea was, I had a chat with Siemens about, you must be having problems at all your centres. We need to engage medical physics, and it wasn't me that organised the Clarity ones, Greg. It was Lorna at the Christie. So big up Lorna for that one. It wasn't me.
Sorry.
But no, don't apologise to me. It made me sound great, but I'm not. I think we need to do something similar. And it doesn't need to go on every single year, unless Siemens particularly want to take me for a curry every year, which I'm fine. But the idea of this meeting, it'll be held in Nottingham in October or November. They're just sorting out dates and trying to get Philip Bernhardt across from the factory and maybe hopefully one of his colleagues. The idea is that they will do some teaching and we will do some sharing of our data. Because obviously we've only had an hour and we've already gone over, but we've been playing around with CNR. It would be wonderful if we could do CNR with the objects that they're expecting in the beam. I don't think they recognize the object. You just tell it what it needs to think is in the beam and it sorts itself out for that. If you tell it the wrong thing, it'll give you crap image quality. So we've got a plate with various, like wires, platinum coils, God knows what. And we're just starting to try and understand, can we get the CNR off in some meaningful way from that? It's static, but we do have a moving phantom. But if you have a moving phantom, you've got to move it at the rate that is set in the editor protocol, because that will set the amount of recursive filtering. I'm not 100% sure. And I think the one thing that Siemens are doing very badly at the moment compared to Philips when they launched Clarity is, even though they're obviously not going to give you the algorithms, I have not got a clue really what their image processing is doing. Whereas with the Philips Clarity, at least I understand the concepts of it. So I think one of the things I'd like to get out of this day is to put the pressure on Philip Bernhardt and his crew to tell us more about the image processing and how that works, because we've had issues with image quality when it first went in. It was tweaked, didn't change the doses, they just changed the image processing set. So we haven't actually played with any of the IQ sets or the gradients yet, because we don't understand what it'll do to everything if we do that. So that's why we've been trying to measure CNR as a function of thickness, platinum and iron. But I haven't yet discussed those results with James Austin, who's the lead for Siemens. So if you had James Austin as your clinical apps, you've got the top guy. And he is good and he's very helpful, but he can't share what he can't share. And some of the things he can't share, I think we need to put the pressure on, because I think they should. Things like what does actually those gradients do for image quality? We need to understand that so we can think about how we might want to change it for different body areas. So all of this stuff, I think in the meeting, getting back to the meeting, it'll be some Siemens, but I think there's a real onus on us to stand up, collaborate, work together, not reinvent the wheel, all of us, and have some sort of national plan. And I think we can do that sort of later this year. And that will help new people coming in, and we can do some work between us and share the workload. Thus, I hope, pushing forward more quickly how we come to a sort of UK position on this thing. There will always be tweaks locally. Everyone's got their own opinion about the shades of grey, but I think we should agree whether it's black or white. So it'll be advertised via FLUG, hopefully, if Siemens agree to that. But hopefully
you.
you're all members of FLUG and we'll see you in July anyway. He said, advertising a FLUG meeting on an IPEM call. Thank you, IPEM. I pay my subs. That's me done.
Okay, thank you, Andy. Right, well, I think we're over time, but thank you everybody for joining and your questions. Thanks to Greg and Charlotte for giving us your experiences there and giving up your time. Please fill in the feedback forms that will be sent, include any questions left that are left, and we'll put them forward to either various meetings that'll be coming up, because I'm sure this will be an ongoing conversation that as we learn more about these units, we'll disseminate to the community. So thank you, everybody.
Thanks, Hannah. Bye.